All right, great. So you can all see my presentation now?
Yes, we can.
Great. So we're gonna switch to a white background for having such a positive message. The very black and dark background there was kind of puzzling to me. But yeah, before many of you joined here, we talked about Stockholm right now, where we haven't had a minute of sunshine for all of December even. So I kind of figured I'm gonna have to go with something lighter here. So okay, so today I'm gonna talk about access control and identity, and I'm gonna kind of see where we come from and where we're going pretty much. So the evolution of access control may be a bit pretentious title, but here we go. So first of all, I'm Anders. I work as a developer advocate at Styra, which is the commercial company behind Open Policy Agent, which I will talk a lot more about today. And I have a background in software development. I've been working as a coder for many years, and tech lead, etc. And the last 6 or 7 years, I've been working primarily with identity systems. So kind of authentication, authorization, knowing who you are in digital systems. As far as Open Policy Agent, I've been kind of involved in this community for the last 2 years, and just started working for Styra. So now I kind of get to do what I love as my job as well. When I'm not working, I enjoy cooking and food in general, football, and as you can see, I got a daughter since June this year. So that's me. Let's get started then. So our kind of journey here starts with the monolith application, and I think you're all fairly familiar with what that entails, since you're a kind of container community. So I'm not gonna stay too long here. But of course, the whole idea of the monolith is that kind of all of these modules are kind of contained within the same like unit, the application. So when we move to microservices, it's not like there's not really a big change in terms of like what kind of components we need. We still need a user interface, we still need to do orchestration, we still need to access data, etc. So the core principles are pretty much the same. What differs, of course, is more or less like how do we talk between these components, and rather than function calls, we kind of change that into network calls. And the whole kind of idea or benefit behind this, of course, is to gain scalability and some form of resilience, so that we're not depending on our app running on a single server or a single machine, but we can scale up and down. So there are many pros of this approach, but there are obviously many challenges as well. And the two we're interested in today, or that we're going to focus on today, is that of authentication and authorization. So for microservices and distributed systems. But before we go there, maybe we can just have a look at kind of the traditional model of doing this, which is that you have a user, and the user provides credentials to the application. And of course, this being a monolith, the application does everything. So the application has an authentication module, which would authenticate the user. It would probably go to some database to verify that the user is allowed to do what they're trying to do. And given that they are, they'd probably make a call to some data, to another database to actually retrieve the data that the user requested. So this is kind of the traditional model of doing access control. It's as you can see, it's a pretty simple model. So moving into authentication for a distributed application, we can't really do this. We'll see soon how, but we can delegate authentication away. But even for microservices, for authorization, this has pretty much up until now been the model of doing it. So each application or service would have look at it, this credential, and they would call some permission data source to see what that user was allowed to do. So we haven't really evolved that much in terms of authorization, while the authentication is often delegated nowadays. So so if we kind of just move this monolith model into microservices, it would probably look something like this. Each service would still do all these calls. So it would just accept, the user would provide their credentials, and the service would go to the user database. It would check that the credentials are in order, and it would have to check that the user was allowed in the permission database. And then it would kind of forward that request to the next service, who would just have to do the same, because they're all kind of self-contained. So this is obviously a naive way of doing microservices, and it's questionable whether we could even call this microservices. But that would be kind of just taking a monolith, breaking it up in smaller components. So where can we improve here then? Well, there's two problems, or with regards to identity, if we can hold off on permissions until later. One obvious problem here is how credentials are passed around in the system. We'd rather not have the services in the backends. Why would they need to know the password of this user? And obviously, if we want to do logging, and it's it would be a pretty big risk that these credentials were leaked. And of course, all these calls to the user database to verify the credentials, that's going to occur a cost, and a pretty big cost if there are many services involved. So it's kind of obvious that this model of dealing with identity does not really scale. So what we can do then is we could delegate the responsibility for authenticating the user to an external service. And that's often what we call an identity system or identity server. So instead of going directly to this service, the user first goes to the identity system to authenticate, and then kind of comes back. And instead of sending their credentials into these services, they have a token that the identity system issued. So instead of sending around these passwords or credentials, each service can just forward a token to see that this is an authenticated user. So by doing this, we kind of cut half of the requests out of the picture. There's no more calls to the user database from these services. So far, so good. However, there's a lot more users wanting access to these systems than just traditional users, and even more so in like modern systems where we have like IoT devices, we have cell phones, we have API clients, we have all manners of clients or devices and users. So kind of to cater for this, or to try and standardize around this, OAuth, and particularly OAuth2, came along. And what OAuth2 did was to define a flow that users or clients, like our robot friends, would use in order to obtain these tokens. And in OAuth, these are called access tokens. So, and OAuth doesn't really say what an access token is, or like the form of an access token. And OAuth, despite its name in the standard, it's called an authorization framework. It doesn't really deal with authorization. There's a few things in OAuth which kind of revolves around authorization with regards to scopes and so on. But primarily, it's about delegation, meaning kind of, this is not my responsibility. Why don't you deal with authentication and authorization? So it's more about like for a way for services to kind of hand off that responsibility to somebody else. And of course, I think most users or most people are, the way they kind of see OAuth is from these kind of social logins. So when you log in with Facebook, you log in with Google, etc. This is pretty much exactly what you do. You're redirected to another identity system where you provide your credentials and you come back with a token. So whether you know it or not, you have all used OAuth2. So like I said, OAuth doesn't really mention much what a token is. And another problem with OAuth is it doesn't really mention what a user is either. So they're all kind of, both tokens and users are kind of abstract concepts. So but of course, there's a whole lot of things in common for all users. And in order to kind of work with that, OpenID Connect came along as a standard which was added on top of OAuth2. So all these flows and all these ways of obtaining tokens and kind of passing them along are still valid with OpenID Connect. It just adds stuff on top. And one of those things they added was the concept of an ID token, which would carry data about users. And it also said what kind of data. So that, like in any system, there's gonna be similarities with the kind of data you have on a user, such as having their email address. That's pretty much, that's gonna be in pretty much any identity system, but maybe phone number, like street address, etc. So OpenID Connect came along with a series of claims, which you recall, which were kind of standardized upon. And there's a whole lot of other features in OIDC, which are pretty nice to work with. So you can, for example, metadata and discovery. So you can, you don't need to hard code as many details of in your apps, but you can rather kind of query the identity system for more facts. And there was also a whole bunch of new flows added for how to obtain not just this access token that you would pass along, but also this ID token, which would be kind of representing the user. So we kind of touched on it here, but what is this token that's going to be sent around? We said before that it was a replacement for credentials, or at least for like password. A token is obviously a sort of credential as well, but we no longer need to pass around a password, so that's good. But what is a token then? And again, OAuth didn't really tell us. And in many cases, a simple token is opaque. it's just going to be any random string or identifier. So like ABC 1, 2, 3. That would be an example of an opaque token. And if you look at an opaque token, it's not going to say anything. There's no facts or there's no data in that token, but you need to go somewhere and provide that token to get some data back. So how do we know what these tokens are when they're sent here, when they're sent to our services? So of course, one way we could do it is to query the identity system. When we get a token in here, we go there and we say, I have this token ABC 1, 2, 3. What does it mean? Is it a valid token? Is it a user behind that? And if there is a user, what is her email address? So that would be one way of doing it. And it's one way you can do it in both OAuth and OpenID Connect. But of course, if we do it like this, we haven't really won much. We're still back to querying an external service whenever credentials of some sort enter our system. So we're kind of back to square one here. So instead of doing this, we commonly use JSON Web Tokens. And the point of JSON Web Tokens is that they're self-contained. So any claim or attributes we have on the user or the robot or the IoT device is contained in the token. So we can look at the token and we can see that this token belongs to Anders, or he is the user behind this request, which means we no longer have to go to this remote server to get that data. And tokens, these JSON Web Tokens are immutable, meaning that they can't be tampered with along the way without kind of the signature of these tokens breaking. So which means we don't, as long as the signature checks out, we don't need to go to the identity system at all. We can just verify the token and knowing that this token was issued by our identity system. And another thing these JSON Web Tokens brought with them was expiry time. Of course, having like passwords expire every hour would be kind of frustrating for users, but they don't really care about these tokens. They just log in, they get a token in return, and it's all done without their involvement. So another big benefit of JSON Web Tokens, of course, it's a pretty popular standard. So there are libraries for dealing with both encoding, decoding, etc. It's everywhere. So one problem here we should just mention in passing, perhaps, is of course that these tokens do contain all data, and that could actually be a problem. Like it's good inside of our systems that we don't need to query an external server, but of course, if you hand a JOT to the user, they can also read what's in there, so they can know that this is the data that they have on me, or that they're going to send into their systems. And of course, that could be potentially sensitive data, and for many, of course, even an email address is considered sensitive data. So it might not be something you want to expose. And another problem with exposing JOTs, and I say JOTs now, I mean JSON Web Tokens, but pronounced JOTs. And another problem with kind of handing that data out to users or external entities is that you may create unknown couplings. And by that, I mean, if you provide them an attribute where it says like first name and last name, and they are writing a mobile app where they want to use your services or your backends, they're going to see that here's the user's first name and here's the user's last name. And they might use that as part of their user interface for their mobile app. So maybe after they log into your service, they're going to say, welcome, Anders. And of course, now you have a coupling between your identity system and some app that you don't even know about. So if you 2 years later decide to, maybe we should concatenate the first name and the last name, then you just now broke 2 million mobile apps, and you had no idea because you were never aware that they used your data like that. So what we may do to kind of mitigate this is we can either exchange tokens or we can actually issue these opaque tokens to anyone outside of the organization. Or we may, of course, just limit what we carry in these JSON Web Tokens, and we say like maybe we only have the user ID and maybe I don't know, a billing unit or something internal, but nothing more than that. And if services need more data, they can go and look it up. And there's also a way of kind of encrypting these jobs, which do make them unreadable for outsiders, but that adds a whole lot of complexity on the other hand. So with all that in place, we're kind of starting to draw the map here of a well-designed identity system. We still have this though. Given now that we kind of established identity, we have a good way of carrying that identity throughout our systems, which is these JSON Web Tokens. But we still haven't really covered permissions. So how would we do that? There are two problems here. There's only one of them, which is visible on screen, which would be like these external calls. But there's another problem here as well, and that's like how do we call this? How do we evaluate what's in this database, and how do we act on that? So how do we deal with policy? And of course, these services could be written in any number of languages, and they often are in many organizations. So what we really want to have here is kind of a unified way of dealing with permissions, regardless of technology choices made. And if we can also cut out some of these calls to the permission service, that would be very nice as well, because of course latency, of course, is essential. So one model we could do here is the gateway model. And the gateway model entails that we kind of put something in front to do authorization or like at the perimeters of our system. So we have one service in front doing authorization checks and then just forwarding them to the services in the backend. And it's of course it's a pretty popular model, and it's one I think works fairly well depending on your organization and like the size of your clusters. And another one would be to kind of move this responsibility to the back here, because in most organizations, what you really want to protect is not the services per se. They are just like code, but it's the actual data. That's where the money is. So it makes sense that would be where you put where you kind of make these permission checks, or that's where you kind of invest. But a problem with that model, and I think to some extent the gateway model too, is now you kind of reinvented the monolith, because now you have these services in certain places doing like a lot of the work, and the other services being lightweight. So you kind of just moved the monolith around. So how can we improve on this? And that's where my favorite topic kind of comes in, and that's of course our open policy agent. So what is Open Policy Agent? I'm sure some of you may know already or have even tried it out. But Open Policy Agent, I'm gonna just say OPA from here on, and I'm sure for many of you that means grandpa or something like that. But OPA is an open source general purpose policy engine. And what a policy engine is a system where you define policies, and then you ask that system questions on that policy. So if you have a policy which says that we can't do any deployments on weekends, and then you deploy that policy, and then you ask anytime you do a deployment, can I deploy this? Can I make this deployment? And it's going to say yes or no. And obviously it's going to say yes on weekdays, and it's going to say no on weekends. So that would be an example of what a policy engine does. And what a policy engine, kind of a benefit of doing this is that it decouples policy from your normal like application or business logic. So your apps don't really need to take into consideration whether a request or a user is allowed or denied, or once the request reaches your app, that's already handled. So it's one less concern and one less responsibility for your microservice. And one thing to note though is your applications are still doing the actual enforcement. So OPA is more like an oracle where you ask them, you ask a question based on your policy and any number of like data sources. So whether it's the time of the day or whether it's your user ID and etc. But it doesn't do actual enforcement. It will just say, no, this is not allowed, and it's still up to you to act on that. And what more OPA offers is a unified way of dealing with policies. So even if you have all these kind of heterogeneous technologies or frameworks running across your clusters, you now have one way of dealing with policies, and not just dealing with policies. I don't mean just like a language for writing policies, but you also have one way of deploying policies and policy changes. So, and you can do that independently of how you deploy application code. So you can make one policy change for 50 microservices in one deployment without actually touching code in any of those services. So that's kind of the beauty of decoupling. And as for offering policies, OPA offers a declarative language for doing that, and I will give you a demo on that in a bit. It's called Rego. And it's, if you're familiar with any other programming language, it's going to take a few hours to get started. So there's that. And again, OPA is a general purpose policy engine, meaning use cases is not just microservice authorization. You can do admission control for Kubernetes. You can have OPA run as close to your data sources as possible and apply policies to data filtering. Maybe your build and deployment pipelines could have policies and so on and so forth. So there's hundreds of use cases for OPA, and this is just covering one of them. But it's a very popular and a very good one to cover, of course. Okay, I don't know what that happened. So instead of all these services calling the permission database, we're kind of moving these arrows or the direction of these arrows. But the first thing to look into here is now these kind of OPAs. These OPA instances. What are they, and how do we deploy them? So that would be the first step, of course, if we want to do something with OPA. It's of course to get OPA installed. And OPA is a self-contained server binary. So it's gonna, the idea is to have OPA running as close to your service as possible. And that often entails running OPA on the same machine, either as a daemon on the same machine or as a sidecar deployment if you're running Kubernetes. And the way your application queries OPA is through its REST API, which is going to be exposed on localhost. So you're going to just query another service running on the same machine. There are other ways of deploying OPA. You can use OPA as a library if you're writing Go applications, since OPA itself is written in Go. If you're using Envoy, Istio, service mesh technologies, you can integrate OPA in that. There's even support for WebAssembly, like compiling your policies into WebAssembly and querying that. So there are many ways of doing this, but I think the most common way is this REST API. So that's OPA and deploying OPA. So what about these policies then? What do they look like, and how do we push them out to these OPAs? Well, I kind of touched on it a bit before, but policies are written in a language called Rego, which is a declarative high-level policy language. And a policy is pretty much a number of rules. We kind of already covered some ideas on what a rule might entail. It could be the time of the day. It could be whether you have a particular role or not. And these rules most commonly would just return whether something is allowed or not. So just true or false. But they're certainly not limited to that. So you can return a string. Maybe you want to provide a reason why somebody was not allowed, for example. Or you can even return a nested object of attributes. And OPA comes with a test framework, so you can even unit test your policies. And there is some great documentation for this, and there's a playground where you can try it out. And I was initially gonna I just did this with more slides to kind of try and show what Rego is about, but I kind of figured there's no better way to show this than to actually do some coding. So even though it's a risky project, I'm going to try and do some live coding here. So I'm going to start an editor, and I hope you can still see my screen. And I'm going to start, I'm just going to create a policy here. I'm just going to call it policy.rego. And we'll just go through this together. So any policy, just as with in many other languages, they all reside in a namespace or a package. So we're just gonna create one. And now we're ready to create our first group. So, and groups can be named anything. OPA doesn't have any like preference on naming. A pretty common rule name would be allow. So we could just do this. We have a name of the rule, and we have a rule body. And the rule body, that's where the action is. That's where like all the statements inside of the body, if they all evaluate to true, then the rule is said to be true. So if we are to just say something like obviously true, then this rule would be true. And that goes for all statements inside here. So if we do something like this, it would require that all these statements inside of the body are true, then the rule is true. So if we add another one here which said something which is not true, then this is no longer true. So of course this isn't much of a policy. So I would rather want to use something, some data which is either from like the outside world or something which we can provide as part of the request. And it's pretty common that you want to provide something as part of the request. You might want to provide this JSON web token, for example, where we have all these details on the user. That would be a good start. But to simplify somewhat here, I'm just going to say we're just going to pretend that in the input there's an attribute called role, and if that role is equal to admin, of course, again, if this is true, then this rule is going to be true. So, and if this is not true, then this won't evaluate. So it's not going to be true, but it's not going to evaluate at all. So one thing we might want to do here is we might want to say by default, if this one does not evaluate, it should be false, or else it's just going to be empty. So now we have our first rule, and we could now deploy this to our OPAs, and anyone who asked, anyone who queried this allow rule and provided a role which is equal to admin would get a response back which said allow is equal to true. So that would be a super simple policy. And of course, even though it's simple, we still would want a way of testing this. So that's what we're going to do here. We're going to say policy test Rego, and I'm going to put this in the same package, but we could put it in another one if we wanted to. And unit tests are rules as well, so it kind of looks pretty much the same. We just prefix them with test, and OPA is going to know that these are tests. So what would we want to start with trying or testing here? Well, probably that if we don't provide an input, then allow should be false. So that would be a good first test. So we're just going to say that by default, we're not allowed. We could also do it like this, but I think this kind of not allow looks kind of nicer. It's more readable. So now we have one test. Given that we don't provide any input, we're not allowed. And now we can run OPA test in this folder, and we should have one test passing. So just by doing this, we kind of get some assurance that we're not that we're doing something right. And we would rather rename it. We should of course say not allow. And another test then would of course be that if we have a role in the input and that role is admin, then you should be allowed. So allow, if admin. And of course, this is just a unit test, so we don't really have any way of sending input to a test. So we're going to have to mock that. And OPA has a pretty good way of allowing us to do that, which is with the with keyword. So we're going to say with input as a map, and we have a role here, and it's admin. Then we should be allowed. So this would kind of mock a user sending in input where they say that they are an admin, or their role is that of an admin. So now we can run the test again, and we can see that it passes. So this in 7 lines of Rego and some tests. This is policy offering, and this is what Rego and this is kind of how simple Rego is in its, at least for a basic policy. And of course you can make this as complex or as simple as you have to, depending on your requirements. But it's not like it's this alien language that you need to learn. It's if you know any simple or just have some basic programming skills, you're gonna grasp this pretty quickly. So that's Rego, and I think I'm ready to return here to the presentation, and that kind of went pretty well. Surprisingly, like given how it was just improvised here a few minutes before starting. So okay, we kind of covered OPA running and how we deploy those. We covered Rego and the policy language we use here. What about this permission data that we used to have in a database? And we still might want to have a database. Of course, if we have like many millions of records or thousands of records, where we describe that this item can only be retrieved if you have this role or if you have that username or whatever, then we still might want to interact with data externally. So there are many ways we can provide OPA with data, and of course JSON Web Tokens would be one of those, which are natively supported by OPA. Another one would be, as you just saw here, to just provide something as part of your query. You say, I have this role, am I allowed or not? And OPA will respond with that. There's also means of kind of packaging up a whole bunch of data and policy and push it out to your OPA instances. That would be the bundle API, where or rather than pushing, OPA actually goes at a regular interval to fetch these bundles of policy data, or you can push the data in that direction. If you have, for some cases, you might actually want or need to have some data retrieved at policy evaluation time. If you just push or pull these bundles, the data is there's gonna be some delay, of course. It's all like, as any distributed system, there are some parts which are eventually consistent. But you can also, from the inside of a policy, use these HTTP send method to retrieve more data. So that would be the permission data. And what about this bundle server here in the middle? OPA provides a number of management APIs, and so that's where OPA can kind of report back, or where it can go and fetch these bundles. And one of these management APIs is the decision log API. So not only can OPA go and fetch policies and data, but also on all these decisions taken, it can actually report back on what decisions it made. So this is of course like crucial if you want to do auditing. Then you have a way of kind of a trail to track all these decisions that OPA did. And this is one thing I think is super hard to get right if you're working in this heterogeneous environments where you have like 8 different programming languages and 8 different logging frameworks, and try and have like a unified way of dealing with authorization logs is just, I have never seen that happen. So that's one big benefit of having a unified way of working with policies and working with OPA, of course. And then there's a couple of other APIs for management, which one is the status API. So all these OPA can report back on how they're doing. And there's another discovery API to manage configuration changes. So yeah, now we're kind of pointing the arrows back here, but this is not, these requests are not done per per request into the service, but they're all asynchronous, so they don't really block the user or like slow the user request down. And now the picture, or like the map, is starting to be complete. We've added OPA here, and we have so we have both like this distributed way of dealing with authorization, but we also have a centralized component where we're kind of all the OPAs phone home for policy updates, and also to report on how they're doing and decisions they have taken. And now the last kind of the last piece of this puzzle, of course, as again we said, OPA is a general purpose policy engine, so there's really no need to stop there. If you can use the same system for Kubernetes authorization, or your CI/CD pipelines, or even to provision infrastructure, you have one unified way of dealing with policies across your whole stack and across your whole organization. And that is what Open Policy Agent is. And now, how do you get started then? Yeah, I think in that demo, that's pretty much the best way to get started. Just learn some of the basics and start very small. Like just start writing a simple policy, add a rule, and try it out. Write a couple of tests. Then have a look at the OPA docs. I think I'm obviously a little biased, but I think there are one of the best, probably one of the better documented technical systems I have worked with so far. So browse the OPA docs and consider like anything you have near you, like anything you don't, after you kind of learn the ropes, have a look at like your previous applications and libraries. Where would OPA fit in here? And of course, what kind of policies are here already? Because your application is probably already doing policies in some regard. It's just not formal. They're just informal, and they're kind of hidden in code. And once you have that, you can start to delegate some responsibilities to OPA. You don't need to kind of rewrite your whole app to use this. Maybe you can just, for a single endpoint, you can start to, instead of dealing with that in code, you rather dispatch that request to OPA. And once you have that, you can start to scale up, of course. Then you can start to look into kind of policy management. How do we distribute this at scale, logging, bundle servers, etc. And I'd be very happy if you all joined us in the OPA Slack community. And that's another great resource to learn more, of course. So that is it about the evolution of access control and about Open Policy Agent. So thank you.
Thank you, Anders.
Much, Anders.
Thank you.
Before I open to the questions, I saw that Kieran left a comment in the chat, and I don't know if you feel still brave enough to challenge the demo gods and try a failing test.
Should we add a failing test?
If you're up for it, yeah.
Yeah, of course. Let's see here. Where's our editor then? Close that one. Yeah, so okay, so let's do allow if developer. So if we just do this and we change the input to developer, then this test should fail. And it does. Of course, what we could do here, and it's another good thing to know, if we want to, like I said here before, for this rule allow to be true, we need all the statements inside of here, the body, to be true, which means, of course, that if we want to add an add or a developer here and say that should, a developer should also be allowed, we couldn't just add that here because now they're not both true. Now it require both an admin role and a developer role. So what we do here, if we have this kind of else condition or condition, so you're either an admin or you're a developer, but in both cases you should be allowed. Then we simply add another rule with that name. So meaning if allow, or if this is true or this is true, then one of these is going to be true, meaning then the whole rule allow is going to be true. So given that we did this, the test should now work. Was that an answer to? It wasn't.
That's exactly what I wanted. Thank you.
Okay, great. Yeah, it wasn't really a question. It was just have a failing test.
Thank you so much, Anders, for this. Any more questions?
I have a question about the policies. You were just showing there that if you need to have an or, then you have multiple policies underneath each other. Is there some kind of convention for these files to make sure that it doesn't turn into a spaghetti nightmare if it gets big?
Oh yeah, there certainly is, and you can work with imports, and you can try and build your policies in as modular fashion as you'd like. So there, it's not just one big giant file. No, but no, I think you can divide it in as many files or modules as you want.
Okay, cool. Thank you.
Is there a level of complexity of the policies where checking the policy would actually become a bottleneck? Is there something you can advise avoiding doing in policies?
Yeah, of course, if you have like these huge data sets like we were talking about, where you have millions of items, then you're gonna have to start think about how you work with those, so you don't. It's just if you work with any database, it's gonna be like the same kind of common sense, like. So you don't scan all of these million of items for each request, but you work with indexing and you work with whatever other means there is, and maybe you work with caching as well, because so you don't need to do a lookup on each request. So yeah, it's certainly not like the OPA is just some magic pixie dust. It's gonna solve all performance problems in with authorization or policies. It does provide you probably the best set of tools that are available for doing it, but yeah, you still need to be smart about it.
Yep, thank you.
Any more for Anders? That's your chance.
No more failing tests.
Well, I've shared some links in the chat as well if people are interested to have more information or join the Slack channel and have a chat there. So feel free. And you are also on Twitter as well, Anders, right?
That's my first name, last name, Anders Eknert. I think it was in there somewhere. I can post it in the chat if not.
Yeah. Perfect. Then if there's no more, I'm gonna, thank you. I'm gonna wrap the meetup, and thank you everybody again for joining us. I think it was a great way to close the last meetup of 2020 against the 2020 odds that are not very nice. So thank you so much again to Anders and Stacy for being our speakers, and wish you all great holidays as well. Thank you.
Thank you.
Thank you for having me.
Thank you.
Bye-bye.
Thank you.
Yeah.
Bye
Thank you,
bye.
Carla and Stacy and others.
Thank you.
Thanks.
Have a good evening.
You too,
You
Judy.
too.
Happy holidays.
Yes, happy holidays.
Bye-bye.
Bye.
Bye bye.